Welcome to Brain Vision.
Hi there. So in this problem, we have a function t, which is defined as, v over 2u plus v. In other words, if you make a little tree diagram as in the book, t depends on the variables u and v. Okay, but also u and v depend on the variables p, q, and r. P, Q, R. So there's our tree diagram in the corner. Let's also write what u and v are. So u equals pq squared of r. Let's rewrite that as r to the 1/2 since this is calculus. And v equals p squared of q to the 1/2 r. Okay. And finally, let's remember p is 2, q is 1, r is 4. So somewhere here, let's just make a note that p, q, r are 2, 1, and 4. Okay, so that'll all be useful. So at this point, we should be ready to start. And the first thing we are asked to find is, partial of t with respect to p. So why don't we use our tree diagram? Right, we want to end at the p's down here, so we'll go down the left branch first, which gives us, right, so we go from t to u, and then from u to p, plus, now the right side of this tree, we go from t to v, and then from v to p. Okay, so one thing at a time here. Let's start with partial of t with respect to u. And for that, let's just look at our definition of t. So partial of t with respect to u, let's use the quotient rule on t over here. So u is our variable as we're considering it. Let's use the quotient rule. So the quotient rule says, you get low, so 2u plus v. The derivative of the numerator, well, the derivative of v with respect to u is 0. Minus, the numerator, which is v, the derivative of the denominator, well, the derivative of 2u with respect to u is just 2. All right. And then all over the denominator squared. Okay, so there's dt du. For du with, not sure where my del went there, partial of u with respect to p. Again, for that, we can just look at our definition of u here, and if p is our variable, the other two are constants. So we will just get q and then square root of r. So that's our derivative of u with respect to p. Okay. Plus, same thing over here, partial of d with respect to v. Once again, we can use quotient rule. So we get the denominator. The derivative of the numerator now is 1 because we're going with respect to v, minus v. Derivative of the denominator is also 1 with respect to v, all over the denominator squared. And finally, dv dp, we can just look at our v over here. And once again, we'll get a similar thing as before. Q to the 1/2 times r. That's the derivative of v with respect to p, the partial there. Okay. So we have our answer. If we just know what to plug in, we can notice right, this is 0. And what are we going to need? Well, we're going to need, we have Q, P, and R values from this point down here. But we're also going to need U and V values at this point. So let's make a note. All right, U at this point equals, well, P is 2, Q is 1, and the square root of 4 will be 2. So 2 times 1 times 2 is 4. And V will be, let's see, 2 times, now we have 1 to the 1/2 power, which is 1, times 4. So we have 2 times 4, which is 8. Okay, so now we can plug everything in. So we get, see, V was 8. 8 times 2 is 16. So we get negative 16 on top. 2U plus V. 2 times 4 is 8. Plus 8 is 16. So we get 16 squared there. Times Q is 1. R is 4. Okay, we're just plugging things in. Now on the other big fraction here. 2U plus V. 2 times 4 is 8. Plus 8 is 16 minus, let's see, V was 8. Our denominator will still be 16 squared times square root of Q is 1 and R is 4. All right, so we're getting somewhere. Let's see, what do we have? Negative 16 over 16 squared. Well, of course, that'll give us negative 1 over 16. Square root of 4 is 2. 16 minus 8 is 8. Times 4 over 16 squared. So let's see, we get negative 1/8 from our first fraction. And for our second one, it looks like we're also getting 1/8 when the dust settles here. Let's see. And so we can, so we can get our final answer here. Of 0. Sorry if there's a pause in there. I'm not sure if the video paused or not. So we have partial t with respect to p. Okay. So the other two will be just the same in spirit. So let's erase what we had, but we'll start from same idea here. And we'll use all the information on the left, so this will be a little quicker. Good. So we now are supposed to get partial of t with respect to q. So we'll replace this down here with a q. And this, again, if we go down the tree, we'll get partial of t with respect to u, and then u, q. Go down the other side of the tree, v, v, q. Okay. Good. Partial of t with respect to u, because we had that before. Okay. So again, quotient rule. If we recall, we had denominator times 0 minus numerator, derivative of the denominator, 2 all over denominator squared. Now, du dq, let's look over here at u again. So we're going to get p times r to the 1/2 plus, let's see, for the next one with respect to v, partial of t will give us again by the quotient rule. Denominator, derivative of the numerator is 1 minus numerator, derivative of the denominator is 1 as well, all over denominator squared. And dv dq, for this one, we'll have to be a little more careful. So now with respect to q, dv dq, the p and the r are constants, but then we add q to the 1/2. So the 1/2 comes in front, we'll get q to the minus 1/2. So you just have to be cautious there. 1/2 pr q to the minus 1/2. Okay, and we plug everything in and see what we get. So as before, when we plug in, see that's 0 there, we'll get -16 on top of our big fraction, and we'll get 16 squared on the bottom. So that has not changed. P is 2, R is 4, which square root of that is 2. Next one, 2u plus v is 16 minus, let's see, v is 8 all over 16 squared times 1/2. P is 2, R is 4, q to the negative 1/2, well, q is 1, so that'll still be 1. Okay, so then we have, let's see, 1/16 times 4 will be -4/16 plus 16 minus 8. Let's see, what else do we have here? We've got, these cancel out. 16 minus 8 is 8. So 8 over 16 squared times 4. We can think of this as 8 times 2 times 2. So once again, it looks like we're going to have -4/16 plus 4/16, which again is 0. Okay. So our last partial we have to get is partial of t with respect to r. And to do that, let's be a little smarter in what we erase this time, because dt du and dt dv, those will not change. All that'll change will be these partials. So let's erase that. Oops. We might as well actually put some of those back. Let's see, yes. So these fractions will stay the same. All that we need to change are these partials on the afterwards here. Okay, good. So in other words, all that will change, are these right there. So let's erase those. And we'll finish off the problem. So over here, we are now supposed to get partial of t with respect to r. And that means this will become partial of u with respect to r, partial of v with respect to r. So partial of u with respect to r. Again, look at the definition of u, but we should get p, q. Now we need times 1/2 r to the negative 1/2. And the partial of v with respect to r is just p q to the 1/2. Okay, so plug in as before. P times Q, 2 times 1, just 2, times a half, times R to the negative 1/2. R is 4. So 4 to the negative 1/2 is 1 over the square root of 4. So that's 1/2. And then over on the right, P is 2, Q is 1. So that's all we're going to get. And let's see. So we have negative 1/16. 2 times a half is 1 times another 1/2 there. 16 minus 8, of course, is 8. 16 squared times 2. So negative 1/16 times 1/2, we get negative 1/32 plus 8 times 2 is 16 over 16 squared is 1/16. And negative 1/32 plus 1/16 is 1 over 32. So this one does not come out to 0. And we are done. Hopefully that helped.